Okay, so this is the second review for relations and functions topic. And so there are about 7 problems or so on this review, and they're dealing with relations and functions. So let's look at number one. So number one, we have this. So you have this linear equation, 4x plus 3y equal negative 24. So negative 4x plus 3y equal negative 24. And the problem says this: you want to graph this linear equation, and you want to and by finding and plotting the intercepts. All right, now remember this is a linear equation, right? That's a linear equation. And remember the graph of a linear equation is a line. And remember to graph a line you need at least 2 points. Well, the points they want you to use are the intercepts. So remember in our lessons we learned about intercepts. So we learned that wherever a graph crosses the y-axis, that's the y-intercept. So those are y-intercepts right here. And wherever a graph crosses the x-axis, wherever a graph crosses the x-axis, those are x-intercepts. So x-intercepts. So these are x-intercepts. These are y-intercepts. Okay. Now, one thing you learned in the lesson was that no matter where you are on the y-axis, no matter where you are on the y-axis, the x-coordinate is always the same. It's always 0. And no matter where you are on the x-axis, no matter where you are on the x-axis, the y-coordinate is always 0. So what you learned in those lessons was this: to find the x-intercept, intercept, to find the x-intercept, the point where the graph crosses the x-axis, you're going to let y equal 0. So let y equal 0. So you go to your equation, and wherever you see the variable y, you're going to substitute 0. So I get negative 4x plus 3 times 0, so I'm letting y be 0, equal negative 24. Well, 3 times 0 is 0, so this right here becomes negative 4x equal negative 24. And notice I have this linear equation. And you all know that to solve for x, right now multiplying by negative 4, to get x by itself, you're going to divide by negative 4. And so negative 4 divided by negative 4 is 1. 1 times x is x. So I get my x-intercept to be, and then negative 24 divided by negative 4 is a positive 6. And then to write it though, so you are going to have to state the x-intercept. So there are a couple ways to do it. You can say x-intercept equals 6, or as an ordered pair, you can say, and it's important what's your x and what's your y. So remember, ordered pair, you put x first and then y. So notice this is your x. So your x coordinate 6, and y, remember, 0. All right. So be careful. It's 6 0, not 0 6. 0 6 is a different point than 6 0. All right. So there's your x intercept. Now to find the y-intercept, remember the y-intercept, you're going to let x equal 0. So let x equal 0. And same thing. So let me go ahead and rewrite the equation. So here was the equation: negative 4x plus 3y equal negative 24. And so where we see the variable x, you're going to substitute 0. So I get negative 4 times 0 plus 3 times y equal negative 24. Negative 4 times 0 is 0. So 0 plus 3y is 3y equal negative 24. And then to get it y by itself, you can divide both sides by 3. And so 3 divided by 3 is 1. 1 times y is y. So I get my y-intercept to be a negative 8. Negative 24 divided by 3 is a negative 8. All right, now you're going to graph it. So in your graph paper, it's very easy to graph. Oh, and by the way, how to write it. So you're going to say the answer. You're going to say y-intercept equals negative 8, or as an ordered pair, you would say 0, negative 8. All right. Okay, so let's go ahead and plot those points. So now we're going to plot them. All right, so remember the directions said, graph this by plotting the intercept. So we found 2 points, and that's all we need are 2 points to graph a line. So the first one is the x-intercept is 6. So on the x-axis, I'm going to put a dot on 6. That's 6. There's your x-axis. And then your y-intercept's negative 8. So here's my y-intercept. -8 right here, put a dot there, and then you draw your line. Make sure, it's important, listen to me, make sure it goes through those points and you use arrows. Put arrows. If you leave the arrows off, you're going to be upset because you're not going to get all your points. Arrows, okay? All right, if you don't put arrows, it's a segment instead of a line. All right, so that, oh, and if you do it by hand, let me show you something. So some of you don't have graph paper. Now remember, when you take your next math course online, make sure you get graph paper because you're going to need them. If you do it by hand, it's very difficult to do a lot of graphs in an algebra course by hand. So make sure you have access to graph paper. All right, if you do it by hand, now doing these lines by hand is not that difficult, but all these other things you're going to graph in the future, like parabolas and quadratic functions, rational functions, exponential functions, log functions, you're going to need graph paper. So make sure you get graph paper. So if you can do this by hand, it's important you use a ruler to help you to draw as good a graph as possible. Now here's what some of you are going to do. You're gonna do something like this. Now before you draw your arrow right here to indicate your x and y axis, let's just make sure we have enough room to do this. So remember your x-intercept was 6. So you're going to go 1, and notice that the distance here has to be the same with all these little tick marks. So that same distance 2, that same distance 3, that same distance 4, 5, 6. I'm going to go ahead and extend this. So there's 6. Put a 6 there. All right. And then I need to go down 8. So your y-intercept number is -8. So same, you see that distance here? They all look the same? Do the same thing here. 1, -1, -2, -3, -4, -5, -6, 1, 2, 3, 4, 5, 6, -7, -8. See, I had to extend it. So this is -8. All right. And then you just use your arrow. I'm sorry, your ruler. Use your ruler now, connect them. Go through them and draw your arrows. And that's it. That's all you do. So that is number 1. Okay, that's number 1. Okay, now in number 2, 3, and 4, in 2, 3, and 4, you're given a finite set of ordered pairs. So this relation, so remember relation is a set of ordered pairs. And in fact, all these are relations as well, because notice that this graph right here is made up of a set of ordered pairs. So that's a relation, that's a relation. So that's one of the things you learned in your lesson, was that there are multiple ways of indicating a relation. This equation here is a relation, because when we graphed it, wasn't it made up of a set of ordered pairs? So all these are ordered pairs on this line. So equations are relations, set of ordered pairs are relations, graphs represent relations, and so on. Now in 2, 3, and 4, though, you're given a finite set of ordered pairs. So this relation has 1, 2, 3, 4, 5 ordered pairs. This one has 1, 2, 3, 4, 1, 2, 3, 4, 5. All right. Now in 2, 3, and 4, you're asked to do this. Determine if the relation is a function, and then determine the domain and range of the relation. All right, so let me go ahead and rewrite this over. So this is number 2. So here's our relation. So this is the notation for a set. So this relation consists of the set of ordered pairs -8, -1, 7, 4, -3, 6, 2, 3, and 10, -5. All right, and then part A, you want to determine if this relation is a function. So remember, the definition of function says that, let me go and kind of write it here. So function is a relation in which for each x coordinate there is only one y coordinate assigned to it. Okay, so for each x coordinate, there's only one y coordinate. And one of the things you learned in those lessons was that when you're given a set of ordered pairs, where it's a finite set, finite meaning you can count them, 1, 2, 3, 4, 5, there are 5 of them, it's a good idea to use the idea of a mapping. So you have x here, and you have your y's. So your domain, your range. And as you list them, only list them once. So if an x value occurs more than once, you still list it just once. If the same thing for the y. If a y value occurs more than once, you only list it once here. Okay? All right, so when x is -8, my y value is -1. All right, so you draw your arrow going towards it. The next ordered pair, when x is 7, my y value is 4. When x is -3, now again, I don't see a -3, so I'm going to rewrite it. I'm going to write it. My y value is 6. I don't see a 6. I'm going to write it. When x is 2, I don't see a 2. I'm going to write it. My y value is 3. I don't see a 3. I'm going to write it. My x value is 10. I'm going to write it. My y value is -5. I don't see it. I'm going to write it. And so notice for each of those x coordinates, there's only one y coordinate assigned to it. When x is -8, I only see a -1. Definition of function. When x is 7, I only see a 4. When x is -3, I only see a 6, and so on. So this is a function. This is a function. All right, now, so that was part A. In part B, they want you to indicate the domain and range. Domain and range. Remember, the domain is a set of x coordinates. So you just list your x coordinates. Some x coordinates are -8, 7, -3, 2, and 10. And you don't have to put them in numerical order. You just write like as you see it. My range is -1, 4, 6, 3, and -5. All right, so I have 1, 2, 3, 4, 5. Make sure you have 5. 1, 2, 3, 4, 5. Make sure you have 5. Okay? And remember, if you only list them once. If they occur more than once, you only list them once here. Otherwise, you won't get all your points. So that was number 2. Okay, let's look at number 3. In number 3, we have this relation. We have 5, -1. We have the other ordered pair, -2, 5. We have 6, 3. And we have -2, 9. Okay? And so again, you want to determine if this relation is a function. That's part A. So to do that, you do your mapping just like we did this. So here's x, and here's y. So remember, x is your domain, y is your range. So when x is 5, my y value is -1. When x is -2, my y value is 5. So far we're good. For each of these x coordinates, there's only one y value attached to it. When x is 6, my y value is 3. So far we're good. When x is -2, now remember, you already have it listed, so don't list it again. Do not list it again. You already have it listed. When x is -2, my y value is 9. Now remember, the definition of function says that for each x coordinate, there's only one y value assigned to it. Notice that when x is -2, when x equals -2, there are 2, 5 and 9, there are 2 different y values. So therefore, this is not a function. Okay, so this relation is not a function. All right, so even though it's not a function, you can still, for a relation, indicate the domain and range. So the domain is the set of x coordinates, and you only list it once. So you see -2 in your set of ordered pairs occurred, there were 2 points with the same x coordinate, but only listed once. So 5, -2, 6. I'll be looking for that. The range, you list your y coordinates. So -1, 5, 3, and 9. 1, 5, 3, and 9. And that's it. Okay, so don't forget, you only list it once. Number 4, so number 4, we have this relation. We have 0, -1, -2, -3, 7, -1, negative 4, 7, 3, 4. All right. So we got to determine if this relation is a function. So again, use a mapping. It does help. And remember, the definition of function says for each x, it's got to be one y. So let's see if we only have one arrow going from each x to a y. So when x is 0, my y value is negative 1. When x is negative 2, my y value is negative 3. When x is 7, my y value is negative 1. I already have negative 1. Only list it once. Just like this. When x is negative 4, my y value is 7. When x is 3, my y value is 4. So I want you to notice definition of function. For each x, there's only one y value. So you see that negative 1 as a y is attached to two different x values, but that's okay. That is okay. Definition of function says this. For each x, there's got to be only one y. So when x is 0, what's the y value? Negative 1. That's the only one. When x is negative 2, what's the y value? Negative 3. When x is 7, what's the y value? Negative 1, and it's just negative 1. When x is negative 4, there's only one y value, which is 7. When x is 3, there's only one y value, which is 4. So this is a function. All right, and then B, again, list the domain and range. So remember, the domain is a set of x coordinates, so you only list them. 0, and again, only list them once. Negative 2, 7, negative 4, and 3. And your range, negative 1, only list it once. Negative 3, 7, 4. Okay? All right, now number 5a. So in 5, you're given a graph. Remember, these are relations, a set of ordered pairs. So graphs represent relations. And you want to determine, though, if it's a function. So when we talked about the set of ordered pairs, a finite set of ordered pairs, we determine a function using the idea of a mapping. When a graph is given, it is so much easier to use the vertical line test to determine that. All right. So, for example, in letter A, we have this is what a graph looks like. So I'm going to go ahead and redraw it. I'm going to just do a quick graph of it. Looks like this. Okay. So the vertical line test says this. You can use a vertical line to determine if a relation represents a function, and a relation is going to be a function if the vertical line intersects the graph once everywhere. So notice right away, right here, and a bunch of other places, right here, if you look at these 2 points where the graph crosses, where the vertical line crosses the graph, that means this, that for these 2 points, the x coordinate is the same, but the y values are different. So therefore, it fails the vertical line test. So there's even an infinite number of places where that happens. So when whatever x is here, you have 2 different y values. Whatever x is here, the x coordinate is the same, right? Because that's this same x value right here. The y values are different. So this fails the vertical line test. Fails the vertical line test. I'm going to put VLT, vertical line test. So therefore, it's not a function. So this relation is not a function. Okay? All right, so that's 5A. 5B, you're given this for 5B. So this is your graph here in 5B. So it looks something like this. So here's 5B. All right, looks like this. I'm going to just kind of draw it like this. So again, if you look at the vertical line test, we notice that no matter where I draw that vertical line, no matter where I draw it, right, it intersects it just once everywhere. So what that means is this. If you look at this point here, for this x coordinate, there's only one y value. For this x coordinate, there's only one y value. For this x coordinate, there's only one y value, and so on. So it passes the vertical line test. So this relation is a function. All right. Now, the other thing that you learned when studying those lessons was the idea of evaluating functions. So when evaluating functions, for example, let's look at number 6. So evaluating functions. If you look at number 6, so in number 6, you're given this function f of x is negative 5x squared plus 2. So f of x is negative 5x squared plus 2. And you want to find f of negative 4. You want to find f of negative 4. So we're dealing with function notation here. And so remember, f of x means the same thing as y. The same thing as y. And basically, see, this is f of x, right? So x, where we see the variable x, you can substitute negative 4. So this is f of x, so f of negative 4. So where we see the variable x, you substitute negative 4. Now remember, in our lessons, you learned that, again, the f of x is y, so this means the same thing as y equals negative 5x plus 2, 5x squared plus 2. And basically, you use a t-table in the past. So what this means is this. When x is negative 4, what is this y value? That's the question. And so when you did this, you said, well, to find the y value, if I let x be negative 4, in place of x, I'm going to substitute negative 4. So I get y equal negative 5 times negative 4 squared plus 2, right? You remember all that? And then negative 4 squared is 16. And then you would say, well, 16 times a negative 5 will give me a negative 80. And a negative 80 plus 2 is a negative 78. That's what you did in the past. But now with function notation, we don't look at it at a t-table. We just go to our function, and since this is f of x, I'm going to go to my function f here, and wherever we see the variable x, I'll substitute negative 4. So basically, you're going to say this is going to equal negative 5 times negative 4 squared plus 2, which is the same thing we did here. And then using the order of operations, negative 4 squared is 16, so negative 5 times 16 plus 2, so I get negative 80 plus 2, which is negative 78. And so your answer, you're going to say this. You're going to say f of negative 4 is a negative 78. And so basically what you found is this. When x is negative 4, your y value is negative 78. And that's the same idea as using a t-table. Okay? But you got to get used to the idea of function notation now. So you're going to get away from this idea of representing a function using y and x to representing function notation. All right, let's see number 7. Now number 7, we have this for number 7. So you have, this time you have g of x. Now be careful when you rewrite it. This is absolute value bars right here. So g of x is the absolute value of 4 minus 3x. Okay, so inside this absolute value bars is the expression 4 minus 3x. And you want to find g of 5. Well, again, just with function notation, this right here represents x right here. So in place of x, you're going to substitute 5. So you're going to say g of 5 will equal absolute value. Don't forget those absolute value bars. Those are important. 4 minus 3 times 5. Okay. Now work within the absolute value bars. Don't throw the absolute value bars away. Work within that. So this becomes the absolute value of 4 minus 15. Notice I still have those absolute value bars. 4 minus 15 is a negative 11. I still have those absolute value bars. Now you're going to ask yourself this. Since I only have one number right here, since I only have one real number, I know that the absolute value of a negative 11 is a positive 11. So now we remove the absolute value bars. So the absolute value of negative 11 is a positive 11. And so therefore your answer, you're going to say g of 5 will equal 11. And that's your answer. All right. So that is the review of review number 2 for relations and functions.